An IP address, Internet Protocol address, is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. It serves as an identifier for the device, allowing it to send and receive data over the Internet or a local network. IP addresses consist of a series of numbers separated by periods, e.g., 192.168.0.1. They come in two versions, IPv4, Internet Protocol version 4, and IPv6, Internet Protocol version 6. IPv4 addresses are the most common and are 32-bit addresses, which means they consist of 4 sets of numbers ranging from 0 to 255. For example, 192.168.1.1 is a typical IPv4 address used for devices on a local network. IPv6 addresses, on the other hand, are 128-bit addresses represented in hexadecimal notation and are designed to provide a larger pool of available addresses to accommodate the growing number of Internet-connected devices. IP addresses are crucial for enabling communication between devices on a network. When you access a website or send an email, your device uses the IP address to identify the destination server and establish a connection to transfer data. Additionally, IP addresses play a fundamental role in routing data packets across the Internet, ensuring that information reaches its intended destination. IPv4, Internet Protocol version 4, addresses are divided into 5 classes: A, B, C, D, and E. Each class has a different range of IP addresses, which were originally designated for specific purposes. Here is an overview of each class. 1. Class A. 1. Range 0.0.0.0 to 127.255.255.255. 2. Class A addresses are identified by the first bit being set to 0. 3. Used for large networks with many hosts, devices. 3. Class A networks have a very large number of available host addresses. 4. The IP addresses from 0.0.0.0 to 127.255.255.255 are reserved for Class A addresses, but some specific ranges within this class are reserved for special purposes. 1. Class B. 1. Range 128.0.0.0 to 191.255.255.255. 2. Class B addresses are identified by the first 2 bits being set to 10. 3. Used for medium-sized networks with a moderate number of hosts. 3. Class B networks have a smaller number of available host addresses compared to Class A. 1. Class C. 1. Range 192.0.0.0 to 223.255.255.255. 2. Class C addresses are identified by the first 3 bits being set to 110. 3. Used for smaller networks with a limited number of hosts. 3. Class C networks have fewer available host addresses compared to Class B. 1. Class D. 1. Range 224.0.0.0 to 239.255.255.255. 2. Class D addresses are identified by the first 4 bits being set to 1110. 3. Reserved for multicast addresses, used for one-to-many communication where data is sent to a group of hosts simultaneously. 1. Class E. 1. Range 240.0.0.0 to 255.255.255.255. 2. Class E addresses are identified by the first 4 bits being set to 1111. 3. Reserved for experimental or future use and not intended for regular host addresses on the Internet. It's important to note that the IPv4 address space has been exhausted, leading to the adoption of IPv6, which provides a much larger pool of IP addresses to support the increasing number of Internet-connected devices. Please subscribe my channel. Thanks for watching.